I suspect everybody knows about the explosion of Space Shuttle Challenger in 1986. It was an incredible event, unexpected, sad, killed the astronaut. Had lots of publicity because we had the teacher in space on board. It was pretty much unmitigated disaster. So I'm going to talk about what caused it. I was driving into my parking place in NASA headquarters on that day, and people met me at the elevator. And I'd been coming back from Goddard Space Flight Center at a meeting in the early morning, and had not had the radio on, or maybe had on a classical station. And they told me, Charlie, this Challenger exploded. Now, why did they approach me about this? The reason was that I had a small satellite in the cargo bay called a Spartan. In the shuttle world, 2,000 kilograms is small, and it was what's called a backup payload or hitchhiker payload. It wasn't central to the mission. I didn't think it's important enough to go to Florida for. But the first thought that I had, I went up to my office, cleared my calendar, as I suspect most people did, and turned on the radio, listened to Mozart's Requiem, and ponder what had happened because I didn't know if my little satellite had caused the problem. When I got home that night, my children, that's not a real picture of them, that's just a stock photo. My children who were in high school had watched it on television. In fact, the whole country watched it because the teacher in space was such a big deal. And there she is, that's Krista McAuliffe. And of course, she perished in the thing too. So my little satellite turns out had nothing to do with it. It was a very icy day in Florida, ice everywhere, very unusual. January day. My colleagues, and I knew these people well, decided to launch anyway. And what happened was that there's these solid rocket motors, there's two of them. These have very high thrust for a fairly short period of time. It's actually a controlled explosion. The solid means it's got an eraser like material inside that has channels in it, and it burns very, very rapidly. And it was put together in sections. And the sections had rubber gaskets called O-rings. And the two O-rings here leaked hot gas, and it came out, and you can kind of see it here spewing out of one of the boosters. The fuel tank is full of liquid hydrogen, liquid oxygen, exploded the fuel tank and killed everybody. So what's your bet? Do you think it was technical difficulties that caused this, or social context? Well, I watched this very closely, and an unusual thing, my revered physicist colleague Richard Feynman was on the review board, and I've got this on C-SPAN in my office, watching it every day because I'm so interested. And he took a piece of the rubber O-ring material and put it in ice water, and showed that it got stiff. So I said, okay, it's a technical error. My assumption was that the temperature regime was so unusual, there was no data for it, and people just didn't have the technical information to decide. Well, that turned out to be totally the wrong answer. So I didn't realize until about 10 years later when I came across a book by sociologist Diane Vaughan, and she was made a member of the Failure Review Board. And this is a sentence from her book. Why did they proceed to launch when all the data suggested otherwise? Indeed. She said the behavior was they required ever stronger technical arguments to delay a launch than continue, and she called this normalization of deviance. What she means is when a behavior that is deviant in an ordinary broader sense becomes unnoticed, and that's exactly what happened here. What was the social context that could cause them to ignore their years of training and experience? So the space shuttle was what was came along after Apollo, and NASA originally wanted a space shuttle that had a manned booster and a rocket on top going to a space station. And the administrator at the time went to President Richard Nixon. He said, "You can have one of the three things. What do you want?" And they said, "Well, we'll take the space shuttle." Now, the question was how to market it. And NASA decided that because it was reusable, and by the way, I don't think that's really a apt term looking back on it. Reusable, something that takes 6 months to refurb is not really reusable. Elon Musk is on the right track here. He calls reusable something you can turn around ultimately as rapidly as an airplane. Anyway, the idea was because it was reusing the main expensive parts, the wing thing called the orbiter with its engines, that it was going to be cheap. So NASA said we're going to launch it 50 times a year, and what it's going to give is cheap, reliable, routine access to space like an airplane does for domestic travel. It wasn't long after the thing started operating when they realized the refurbishment was so complex. These main engines are operating at the limits of what the materials can take. It's a very sophisticated engine, and they're launching it 24 times a year, getting slower and slower and slower. So at the time of Challenger, it's only launching 10 times a year. But the budget, NASA budget for the space shuttle was more or less constant, which means the cost per flight went up by a factor of 5. So instead of being the cheapest access to space, it became the most expensive access to space. Now, this next part, I'm going to speculate. I think the senior NASA management, the space shuttle was NASA, just like Apollo was NASA before, the science program being sort of incidental. And people thought that if the shuttle gets canceled because it's not doing what it's promised, that's the end of NASA. And the one thing people at NASA don't want is the end of NASA. So the pressure to launch from management was fantastic. Moreover, NASA spends 90% of its funds typically on contractors. In this case, the contractor building the solid rocket motor was Thiokol, a company in Utah, and they would have had to agree to launch. The problem was that the relationship with the contractor was broken because, as Diane Vaughn described it in her book, NASA was called the bad news boys, nothing but criticism. And so communications broke down. And just as we were to see years later with Hubble, the contractor stopped telling us about bad things that they didn't want to hear. So it's a longer story, but fundamentally what happened was NASA people, NASA engineers figured out not long before Challenger's launch that the risk was being mischaracterized. So in NASA, we put a criticality number on risk, and criticality 1, or what we summarize as crit 1, means if the risk occurs, it's loss of crew, which means loss of mission, which means loss of crew, loss of everything. And there were 2 O-rings. So the contractor in NASA had originally characterized this as criticality 1 redundant. Now, redundant means you don't worry as much. The implication is you can have one of 2 things fail and it's going to be okay. But NASA engineers figured out that if you don't have that failure with the first blast of the starting of the engine, the rocket motor, then there's not enough gas to seat the second O-ring. So in fact, it's criticality 1, not criticality 1R. So the contractor's management overrode its own technical people and said, we're go for launch. What happened? The social diagnosis is this is blind obedience to authority overrode judgment. And the government has a lot of power over contractors. Most of the contracts are what we call award fee. What that means is that there's a profit that's negotiated at the time of the contract as a fixed amount for a maximum. And the government can allocate that arbitrarily in any way they want. And everybody's okay with the system. And so the contractor management, looking at the profit on the line, gave in, and NASA management, worrying about the shuttle flight rate, demanded launch. And so blind obedience to authority overrode judgment of competent, well-meaning people. Now, the reason I'm talking about this is not just because it's interesting and I was personally involved in it, but Diane Vaughn's book moved me powerfully. This is the sentence that just got me. She said, "It is unfortunate that the sociological explanation is the correct one, as these invisible and unacknowledged forces elude remedy." Wow, that's huge. Invisible forces, yes, she's right. The social context is an invisible force. Unacknowledged, she's right. No one ever even talked about this. No one knew it was there. And it eluded, for those reasons, it eluded remedy. Trying to think of a more ordinary example of this, I'm sure you're all familiar with the frog in boiling water story, incremental stupidity, same thing. And again, we have difficulty noticing slowly developing events. The humans are kind of have that limitation. Now, because I didn't pay any attention to this, I had a much more difficult year in 1990 with the launching of Hubble Space Telescope. We'll take that up in the next session. Hope you can make it. Thank you very much and enjoyed showing you this. Be safe. Bye-bye.